Hello. Hello, delay of up to 15 seconds. Hello. Today it's only 5 seconds. Welcome back, little gaming community, to the stream on this Saturday, where we are going to develop the Parallax map background from our game. That's what we are going to do today. I had a great day. If anyone is interested and asks, I helped my father again in his new house with some TV stuff, which is a little bit more complicated than he expected, but we made it happen. Everything is working now. I went for lunch as well with my mother and father together, which was also nice. Today was a great weather in Austria, very hot. And I visited my grandparents from father's side. And they were also in a very good mood. They are 90 and 89, I think, if I'm not mistaken. So quite old, but they are still mentally and also physically very fit, which is always a pleasure for me to see them like that. I like it when my family and friends are in a good mood, physically and mentally okay. That's the best thing that can happen. Good, but we are more interested in game development, and today we are going to implement a Parallax map background. And by the way, you might not know that, but there is support for that in tiled for Parallax effect. Let me just to show you something to show you the effect in tiled. Let's just select these tiles here and put them in the foreground. It doesn't really matter where we can see this effect. And let me paste them here a little bit like that. And on the left side, you have the parallax factor, which means currently it's 1. So everything is moving with the same speed. But we could change that to, for example, 2. And then you already see that this foreground layer here is moving faster than the background. And according to whatever we change the camera position here, then the foreground will also move a little bit. If it would be less than 1, for example 0.5, then it simply moves a little bit slower, but still we have this effect of this parallax background. In our case, it was a foreground. And this is also supported by LibGDX, because for that functionality here, I created a PR like, I don't know, was it 3 or 4 years ago? And it took those guys forever to review it and approve it. And at some point, I simply lost interest and I didn't follow the issue anymore. Because for me personally, it took way too long for them to review it, which is not so good in my opinion. They could improve on that. But there was another interested guy and motivated guy, and he fixed something in my original PR. And from what I remember with the latest release in LibGDX, this is now officially supported and also correctly supported. But we will not go that route. So we will not paste a background here. That would be too simple. And then just use whatever tiled gives us. We want to learn something today, and you are going to learn something. And I am not 100% sure anymore how everything works, but I'm confident that we are going to solve it. And to start with something, we need, first of all, as always, a graphic that we can use for our background. And there we will use the Pixel Adventure. Was it other? No, it's not other. Is it background? And there, I think we said we will start with the gray background. Not sure if that's the best one, but we will start with this one. And we simply put it under Assets, Graphics, and then let's make a new folder that we call background, and there let's paste in the gray background. Is gray with AI? I thought it's with E and Y. But obviously that's wrong, or that guy typed it wrong. I would write gray like this and not like this, but maybe both ways are correct. I'm not sure. And the thing that we are going to need now is a little bit of a playground, because I'm not 100% sure how we need to solve it, and I don't want to simply copy and paste it from another project. So that's why we are going to implement a screen, and a test screen, and I will call that Parallax test screen, which is, if I remember correctly, it's just a KTX screen. And in here we need a couple of things. And the first thing that we need is a texture. The texture is the texture with a specific path. In our case, it is the... Where is the background? Reload. Okay, here it is. So we need the graphics, backgrounds, and then gray.png. So this is our texture. Then we need a dispose function where we are going to dispose the texture. Then we need a sprite patch to render it. It's basically, it's just a patch. We don't really care. And it's a sprite patch. And also that one we need to dispose. Good. Then do we need a viewport? I'm not sure. Let's try something. So when we go into render now and we simply say sprite patch use, and then it.render draw. How is it called? Draw. We want to draw the texture at position 0, 0. How does that one look? Let's see. Test launcher. Then we need that little test screen now, and let's start it. We should introduce a viewport. We will do that in a moment, but out of curiosity, how does that look if we don't use a viewport? What is then even used? Maybe a screen viewport? Or a stretch viewport? I don't know. Okay, we already see something. Okay, it's definitely getting stretched, so it seems like a stretch viewport is the default behavior if you don't specify anything. Let's change that as well quickly. This is already everything until here is known and nothing too crazy. So we have a viewport, which is a feed viewport with the size of 16 by 9. Then we need the resize behavior where we update our viewport with the width, height, and center the camera once more. And here we just apply the viewport and pass the camera to the sprite patch to render it correctly. And finally, our texture needs to be... Let's do that in the show method. Not sure. No, let's do it here. No, the texture does not get changed. But okay, wait, we need to do it like this. Then the width is 1 and the height is 1, which is not correct. It's actually, how big is the texture here? 64. So it would be 64 times unit scale. And the same for the height. And now we should have the same behavior as before, but now correctly drawn with our world dimensions, and we have the fit viewport. Okay, so that looks already good. We can draw a texture. Amazing stuff. But now we want to duplicate or tile this texture across the entire background. So how do we do that? And here we need to change that a little bit. I am not 100% sure anymore how that worked. I think, is it texture data? There's something with texture and then texture wrap and then repeat. And this one we need to set somehow. But where? Is there a wrap thingy? Ah, here, set wrap on the texture. Okay, and there we take this one here and we set it to repeat. So this is obviously not working. Why not? Ah, we need to set it for the U and V. So for both, for X and Y axis. So we would need to set it like this. How does that help us now? So what does that change? Let's say here, this is our texture size. And now let's make it 2 times. What is now happening? Does it get stretched or does the texture simply get drawn repeatedly? Seems like it simply got bigger. Let's make that now a 3 times 3. Seems like the texture is simply getting drawn 3 times. Yes. So this is actually not what we want. What is that doing? Set wrap. Sets the texture wrap for this texture on the U and V axis. This will bind this texture. Okay. What I want is that this texture keeps its original size and simply gets repeated multiple times in the area where I define it. How does that work? Can I come up with it by myself or do we need to Google? I'm pretty sure we need to Google, but give me one more chance. Give me one more chance. So let's also use a sprite, which is a sprite with the texture that we have. And now let's draw the sprite. Whoops. With the patch that we have. Let's also adjust the sprite a little bit. So let's say the size is equal to this one here. So texture size. The position is 0, 0, just to set it. It's not really important. Yeah, and now we will draw the sprite. Yeah. Now it should theoretically look the same as before, but now we have a sprite. Okay. And now, out of interest, what happens if I set the U and the U2? What are the current values of U and V? So the current value of U and V is 0, 0, 1, 1. Yeah, that makes sense. Now, what happens if I set the U2 to 2 and the V2 also to 2? Do I see the texture now 4 times? I think so. That looks good. And is this now because of the texture wrapping, or did that not change anything at all? What happens if I remove this code here? Aha, now it looks differently. Not sure, but that one here is now gray and we just see the texture here once. But anyway, so this repeating seems to work. So what I would simply need now is a sprite which has the size of our viewport. So it's basically the viewport world width and okay, wait, I cannot save it like that. So the size is the entire background. So the viewport world width and the viewport world height. The texture size is the texture. Aha, we have that also available. So basically, if this is 1 by 1, then we simply stretch the texture through the entire screen. If we set it to 2 by 2, we have it 2 times. So this number here is then actually the texture width multiplied with the unit scale. Is that correct? The texture width is 64 times unit scale. That's not correct. Times viewport world width, maybe, and that one would be texture height times unit scale times viewport world height, but I think that's not even correct. Let's see, how does that look like? What we are currently setting. Whoa, that looks crazy. That is way too much wrapping. So just also out of interest, if that would be 1, then we simply have the gray texture as the entire background. Yes, this is not what we want. So we need the texture width times unit scale. Like this? No, that does not look correct. What do I need? Wait, I have an idea. I think it's the width. So how many tiles do we have space on the x-axis and then divide it by this value? Maybe it's that one. Divided by this one. Maybe that's correct. Let's calculate it. So we have 16 world units. Okay, wait, I need to debug something. But we will come to a solution pretty soon. So we have this value here is 4. Yes. Let me write down something here. So the texture has a size of 64. Our world unit is equal to 16 pixels, which means this one is basically 4 world units. So that's the value that we get here. Also, we have a width of 16, which means I can have 4 textures on the width to fill up the entire viewport. And on the height, we have currently 9, which means on the height, we have 2.5 textures available. And now, how does that look like in reality? So we have 1, 2, 3, 4, and 1, 2, not really half, and a little bit for the background. So I think that's actually correct, what we have here. Let me check one more time. Yes, so we are filling it out like that. This is already great. And now with the sprite, let me check something. There should be a method which is called scrolling. And is this it's the vertices u plus the x amount modulo 1, which gets then set here. So the next time when I call it, it will add something again. So we can try here a scroll of, I don't know, 1 and 1. How does that look like? That does not look good at all. Scroll. Also, it seems like it's not scrolling all the time. Looks like it's just scrolling once, right? Let's try 10. Nah, I would expect that something here is moving, but it does not move. We can third. Let's have here a variable scroll, which is 0. This scroll, we add the delta time. And then we simply scroll here just on the x-axis for now. Okay. That's not working. That one should now scroll. Yes, it does something. But way too weirdly. Maybe scroll is not good enough. Or it cannot be used the way I want to use it. What does that do? Offsets the region relative to the current region. Generally, the region size should be the entire size of the texture. In the directions it is scrolled. Ah, okay, and we don't have that because we update here the U2 and V2. Okay, so scrolling is not what we need. Then what else can we do? We could, let me paint that again. What we could do. So currently we have a viewport, which is whatever dimension. And back there we have now our background sprite like this. And we want to have a parallax background, which means this graphic here can move around. If we would move it to the left, we simply won't get here any output. So we have then a black background color or whatever our clear color would be. Same if we go up and down. Now, theoretically, I could just make that bigger and move it around like this. Then we don't have this issue. But depending on how large our map is and how much we move to the left, we will still always have the same problem. And making this just bigger and bigger, I think, is not a good solution. So maybe maybe we would need a second sprite, so one here and another one here. And basically when that one here is out of the viewport, so if it's not in the viewport anymore, then remove it and place it to the right or something, that you have an endless scrolling effect. Not 100% sure what is the best solution here. Let me check out once more the sprite.scroll method. What is that one doing? So it sets the U1, U2, U3, and U4. And I guess we are actually setting that here as well. So here we set U3 and U4. And what are we doing inside the scroll? There we set all the U's. So we add the scroll amount to U. Then U2 is U plus width divided by texture get width. I think this is not correct. We would need to update that. I think since we have texture wrapping anyway, don't we just add something to U and U2, so this amount, the same amount, so that we simply scroll our frame or region to the right, and that should automatically work. Let's try that out. So let's have, again, a scroll, which is 0. And I would say we just need something like U plus equals, I don't know, 0.1. And sprite U2 plus equals 0.1. I don't need that variable now. Let's see, how does that look like? Yeah, I think, whoa, that's way too fast, but I think that's actually the effect that we need. Yes! Haha! Sometimes I'm a genius. I'm waiting now for the chat to also say, whoa, Simon, you are a genius. I know. Thank you. Okay, that's really working. That's, I think, way better than all the other solutions that I implemented before. I will explain what's happening here at the end, but theoretically, that also means I can now set sprite V and add something, and also do the same with V2. So now it should scroll also up. Haha! Okay, but that's really cool stuff, right? That's very nice. I'm pretty sure I did not solve it like that in the dinosaur game. Okay, so what we simply need is, I would say, maybe a Parallax background class. Yeah. Which maybe... Yeah, let's implement that. So, step by step, let me explain everything. So first of all, we will make a Parallax background class, which maybe loads different backgrounds that we can set in our game. Like currently, we will just have the gray background, but there might be multiple ones in the future, and we can change that whenever we want. So that would be, the textures would be part of this class. The class would also be a disposable, so to clean up the textures. And it will also contain the sprite. And it also needs to react to resize events so that we can then, whenever the viewport size would change, so the world width and world height, we would need to update the size calculation of the sprite. So this one here is important. And we also need to calculate U2 and V2 again, which would also be still important. And it also needs to remember the scroll amount. Yes. And with that, it can also provide maybe a draw method, which takes the sprite batch, similar to the sprite itself, to render it. And that should be everything that we need. So let's optimize what, and also let me explain now what we are actually doing. So why is this one here working? What is this U2, V2 stuff? Let me explain that, or let me try to explain that. I explained it once a little bit. So whenever we have a texture like this, then I explained to you once that there is a U mapping. Whoops, I cannot type here. Let me draw like this. There is a U and a V mapping. U is the mapping from here below is 0, 0 to 1, 1, which would be the top right. And if we render with this mapping, so from 0, 0 to 1, 1, we basically draw the texture as it is to the screen. So there will be no change at all. It's simply drawing it one by one to the screen, which is good. But we don't want that, because what we actually want is that we have a viewport in the background. And what we now want is that this little texture here gets repeated multiple times to fill up the entire background of our game, of our viewport. So this texture here might be smaller, as we can see it here, and we simply want to repeat it multiple times. And the first thing that we need to do is to say that this texture has a wrapping of repeat on the X and also on the Y axis. And we also modify the U2 mapping and the V2 mapping. So instead going from 0, 0 to 1, 1, we go to 0, 0 and then just to a part of the texture. What that simply does is, since we have the texture wrapping active, it simply then repeats the texture again and again, and again. So the effect that we have here is now because of the adjustment of the U2 and V2 mapping. Just one more that maybe it's easier to understand. Let me comment out all these modifications. So that would be and also this one here. So this is how it would look like if we don't do anything special. Then simply, since we set the size of the sprite to the entire width and height of our viewport, then this texture, as you can see it, it simply gets stretched through the entire viewport. This is not what we want. We want to keep the aspect ratio or the size of the original texture, let's call it like that, and simply repeat it then multiple times on the X and the Y axis. Then that would be those two modifications here. So how many times can I fit this graphic on the X-axis? It's basically the width of our viewport divided by the width of the texture. That way, so we scale it to our world units. This is important because the viewport is in world units, but basically it's the viewport width divided by the width of the texture. So like here, this is the width of the viewport, which is maybe, I don't know, 3, and this texture here has a size of 1, which means I could fit that in 3 times on the x-axis. This is basic math. I think that one you understand, I hope. And same on the y-axis. There it's the height, the maximum height from the viewport divided by the height of the texture. If we have this one here, then you can already see that the texture is it's not resized anymore, so it keeps the original size that it has, but still it gets duplicated or repeated on the x and y axis as well. I don't really understand why the color is gray. I actually would expect that it's black, I guess. But what could be that maybe if the U2 and V2 is something outside the texture, so if it's more than 1, for example, which it isn't, I don't really know. I don't know why in that scenario here, the things here are drawn as gray. Not 100% sure. But the second piece, and that's the important one, is that we say here now, if our UV mapping, or if our drawing, let's call it like that, is not with the original mapping, so if we are simply draw the texture again and again and again, so this repetition that we are doing, we say here, repeat it, and with that little line here, we get now the texture that we just had before here on the top left. We now simply repeat it on the x-axis and also on the y-axis. Yeah. That looks good. And yeah, the last part was the scrolling effect, where simply with this U and V mapping, we have like a region in our texture. So maybe our UV mapping is something like that. And with the scrolling, what we basically do, we scroll this frame to the right or to the top and yeah, repeat that endlessly. And since we have this texture wrapping repeat, basically when we are outside here, what it does, since it's repeating everything, it basically goes back to the beginning and starts from here. So we have an endless scrolling effect of this frame. So this is why this entire thing here is working somehow. Yeah, so I would say let's do this class that I mentioned. So I think the best thing would be to put it. We don't have a special package for that, and I think we don't really need it. So let's make the class here and let's call it Parallax background. And as we said, so it's a disposable. So it needs to implement this dispose function. And what it needs to be created is, I'm not even sure. I would say the viewport. Let's call it the game viewport. We don't need to store that. Then what do we need? We need different textures. For now, we just have one, which is this one here. So we will load it and we will call that the, I don't know, gray texture, something like this. And we need to be careful to dispose this texture at the end. And in addition, we need the sprite, which is, let's call that the background sprite, which is simply a new sprite, which has no texture at the beginning, maybe. Yeah, but we currently just support the gray texture, so we will keep it like that. We make it very simple. And this sprite now gets modified a little bit with the logic that we had here. We don't need to set the position, but we need to set those things here. Maybe comment it a little bit. Background sprites that fills out the entire viewport. Also U and V. Is not mapped from 0, 0 to 1, 1. I cannot bring that into words. So let's make that here something like make the texture, or let's call it tile the texture over the entire background by keeping its original aspect ratio, maybe something like that. Good. Then we have that available. Then we need to react to resize events, or maybe just call it. I would say so. Maybe let's just call it. So there we have a function resize, which takes a width and a height, which is, I'm not even sure, is it an integer or a float? Could imagine it's a float, but it's an integer. Okay. So there we need to do the same calculation that we have here again. So maybe let's call that here private function, an extension function of the sprite. And let's call that resize, which takes again the width and the height as an integer. And in here we do this stuff here. So width should be, to make it also more clear, that's the viewport width. Oops. Viewport width. And this one is the viewport height. It's not, it's actually the world width and the world height. Okay, so we can call here resize of game viewport world width and game viewport world height. And we need to still run that inside apply. Okay. And this one we need to make it to a float, or we convert it here to a float. Let's make it here a float. Okay, and when a resize is happening, then we make the background sprite resize as well. And height to float. Okay. That is one part here. So basically we don't need the texture here. We don't need the sprite here. We can now make a parallax background, which is a new parallax background where we pass in the viewport. And in here, when we resize, we also need to call resize on the parallax background. Okay. And finally, we need to dispose the background. So that already cleans up the code quite a bit. And the last thing is now the draw function. And this scroll behavior here. So first of all, we need a draw function, which takes a patch, and it simply is calling the draw function of the background sprite. That's the easy part. And the maybe more tricky part, I'm not 100% sure, would be a scroll function by, I think they called it amount X and amount Y in the sprite. And there we have now this calculation. That's already it. But in addition, one moment. No, that looks okay. In addition, we need something as well. So when we resize, we reset the U2 and V2, but we need to also consider the amount of scrolling that already happened. Because if we don't do that, I think it will reset to its original location and scrolling and so on. And that will not look nice, but let's try that out. Just that we see that. So we have here Parallax background draw. And also we have here Parallax background scroll. Does not really matter here. Then we can remove all of that. And let's try out this test screen once more. Okay, so that looks good, but if I resize now, so you can see there is like a little bit of a flickering, right? Yeah. Actually, not so much. It's just flickering if I resize on the y-axis. Okay, let me see if my idea that I have will solve this issue. So my idea would be that we also need to store the scroll value. Most likely on both directions. Then let's just call that scroll X. Or maybe just scroll amount, and that is a vector 2. And whenever we scroll, we add that to the X amount, then we add the Y amount. We add that up here as well. And finally in the resize in here, we need to have the world width and height. All of that is good stuff. But in addition, we need the scroll amount X and the scroll amount Y when we resize. That would be my idea how to solve that. But let's see if that's working. No, it's not working. Cannot read field X because this scroll amount is null. What? Hä? Why is it null? Hä? Why is it really null? I don't get that. How can scroll amount be null if it gets created? Okay, it gets created below the sprites. Not good, not good. Let's move that to the top. Okay, now it should be good. So resize on the width looks good. Resize on the height is still flickering like crazy. So my solution actually did nothing. Then I would say screw it. Let's remove it so we don't need the scroll amount. Makes it easier, and it's anyway a little bit of a special case because let's be honest, if you are in the game most likely in full screen, you won't resize, and if you do, then whatever the background simply gets restored. Yeah, but that's really not correct. I think we need it. Wait, let me revert everything again. I really think we need it. And why do I think that? Let me show you something. Let's not scroll all the time. Let's debug it in a better way. So GDX input is key pressed. Let's take the key 1. Then we scroll by, I don't know, a half in both directions. Is it num1? Yes, it's num1. And one more when we... No, I just need this for now. Okay. So we scroll by 1. It does it does actually nothing. Then let's scroll by 0.1. Ah, is key pressed? Is key just pressed? I just want to do it once. Not all the time. Okay, now we should see something. Okay, so now we have like the diagonals here almost in the middle. If I resize now, okay, here it simply works, but here it also seems to work. Why is it working? I mean, it's weird that it's flickering when we resize on the y-axis. I don't really understand that. But it seems like the position is still correct. Ah, but wait, but now we have the... Yeah, now we remember it. Now let's remove that once more. So now we don't remember it. And now I expect that it's not working. So again, we have it like this. No, it's still working. It still looks perfect. Okay, so this is not needed at all. I just proved myself wrong. Good, that makes it simpler. So we just need this one. I might want to extract that to a method. Let's call that wrapped texture, which takes the path to whatever texture we want to load. And it returns a texture. Internal path, it's called like that. Then let's also call that here internal path. Then we make that an expression body. We don't need that one here. And since this is now a method, let's bring it down. Like here. Okay, so now at the top I have my attributes. And the sprites. Makes me crazy since I want my attributes at the top together, not with new lines in between. Okay, now I have the effect that I want. Good. Yeah, so what we now have is a Parallax background class that we should theoretically be able to use everywhere. So that is one piece of the puzzle. Whoa, that's way too fast. Yeah. So that looks good. Now we need this little thingy also in our game. So I am wondering where. Maybe in our game screen. And we need it before we create our world. So here we have the Parallax background. And that one takes the game viewport. Then we have a resize method where we need to resize it with the width and the height. So that's also solved, and we need to dispose it. Yeah, done as well. And the last thing is we need to add it here as a dependency. So if a system needs it, then it can have it. And one system that really needs it is the render system, which now takes the Parallax background. Maybe that should be a separate system. It could be, but I think it's also fine if we still have it in here. What I don't like about this system so far, it has quite some things that it takes. It's 1, 2, 3, 4, 5, 6, 7. Yeah, I think 6 and 7 is within a specific tolerance that I can accept. But if it would take more than 7 arguments, then I would definitely refactor it and split it up a little bit. Yeah, so now let's render the background before everything else. Render Parallax background. Draw, and we pass in the sprite batch. I think we have it as an argument. Just pass here the patch. Okay. Now we should have a background. That's the wrong thing. I did not want to start this one. I wanted to start our game. Yes. Ah, okay. I was wondering where did the world go to? But we started at the top of this cliff here. That's good. So we have our background working. Why was there... I think before... Okay, when our player spawns... Where's our camera system? Wait, our camera system does what exactly? The camera seems to be not immediately centered correctly. So position is equal to the sprite x plus the sprite width. And the sprite position gets updated. Where is this in our physics system? In the onAlpha method, I could imagine. Yes, and it's based on the previous position. Haha, I think we have a tiny little mistake. It's not a huge issue, but it's not perfect. When we create the physics component, somewhere here, then we should also set the previous position immediately. Not here. Here. Then we should not just set the body, we should also set the previous position to body.position. We can actually do that here, right? So vector 2, and that one takes the body position X and body position Y. It should be initiated with this position. So now we should be immediately at the top. Yes, now it looks better. Before there was the problem that the previous position is 0, 0. And then it interpolates for a few frames until we are at the top. And that is not correct. So for the initial spawning, we want to have the camera immediately centered here. So that's already good. But there's also one more thing that I think might be wrong. We are centering the camera to the sprite X and Y. No, that is correct. Is that correct? I think so. Yes, because the sprite is the interpolated position. So we are also centering on the interpolated position. Okay, looks good. So we have a game, we have a small bug fix, and we have a background now. Now we want this background to move a little bit. Whenever, how do we actually do that? So I would say we base that on the there are two solutions. So whenever or two solutions that I see. So what we could do, we have our background and we have our player. We could, whenever the player is moving to the right or left, then we are immediately scrolling the background to the right and left with a specific percentage. And how do we know if the player moves to the right or left? We would know that in the camera system. There we know the previous camera position and the new one. And based on that, we could do some scrolling. The other solution that I could think of is that we simply have the distance of the player from the bottom left, so from 0, 0 to wherever the player is currently located. And based on that offset here, we could set also the offset on the background graphic. And I think that this solution, so the calculation of the camera between 0, 0 and wherever we are currently, I think that's also the way how Tiled is implementing the parallax effect. So most likely that's a very good and common solution that other people do as well. I think we will follow that approach. And I am now really tending to make a separate parallax system. I think we make a parallax background system. A Russian name, sorry, I cannot read that. Hi, thanks for your stream. Sorry, I will see later. Big thanks, you are the one man in LibGDX with Kotlin who I see. One question, can you do things so you can create objects in parallax background? It's idea from my game concept. Can you do things so you can create objects in Parallax background? Sorry, I don't understand that. What do you mean with that? Create objects in Parallax background. You would need to explain that to me once more. Okay, coming back to our tiny little problem, we will create now a Parallax system. Parallax background system, let's call it like that. That one is, does it need to iterate? No, it does not need to iterate at all. So it's just an interval system which gets triggered every frame. And what does it need? It needs the camera, because based on the camera, we are applying the parallax effect. So here for sure, we need the game camera, which is just a normal camera, and we can inject it. Then we also need access to our parallax background, which we also inject. Some player will play in background, but some player will play foreground in my multiplayer game in LibGDX. Okay. I can explain to you the idea that I could come up with, but not sure if that will solve your problem. Let's do that in tiled quickly, because there we can represent something very easily. So let's imagine you have one layer, which is your player parallax background, and you have another layer, which is your player parallax foreground. Then in the background, you have, for example, this one here. Zack. And in your foreground, you have, for example, foreground, let's put it here. Okay. Then the background is scrolling a little bit slower, and the foreground is maybe scrolling a little bit faster. So now if the player moves around, we can see, let's make that also a little bit smaller, then it's easier to see. Zip. Okay, so now if the camera moves, so if the player moves, you can see that the background and the foreground, they are moving at a different speed. And what I could imagine now, that what is the background? When you have something on the background, there you have your objects, and basically you don't want that they are colliding with the things in the foreground. So maybe the background entities, there you need to turn off that they are colliding with things in the foreground or interacting with things in the foreground. There we had a couple of solutions already, for example, in the contact listen and box 2D. You could tag them with the, for example, a background entity tag, and those one with a foreground entity tag, so that you know which one is which. If they can maybe teleport through a pipe or portal or whatever between the different grounds of foreground and background, then you could simply update the entity tag. And yeah, then based on that, you could then have your logic. So background entities will just interact with each other, and foreground entities will also just interact with each other based on, for example, entity tags. Yeah, it's 3D in 2D in my game. Yeah, so maybe something like that could work. If you use box 2D, yeah, but there you can also just use, for example, the pre-solve and make background entities not collide with foreground entities. So that would work. And your other game logic simply needs to be adapted. Yeah, I think that should in theory work. Not sure if that's the best solution, but just to come up with something very quickly, that would be one way how you could solve that. So tagging your entities to know if they are in the background or in the foreground, and then based on these tags, do something special. Let them react or not. Okay, Parallax background system. That one also needs the... Okay, but what we are now breaking, which is maybe not ideal. So here we render everything within one call with the sprite patch. But now I'm removing that part here. So we definitely have two calls to sprite patch begin and sprite patch.end. But I don't think that's a big issue. I will enable the profiling once more. Let's do it now that we don't forget about it. But I'm pretty sure that this is not killing our performance at all. So that should be fine. So we also here need access to our patch, which we inject as well. And since this one is also the first system, so this system, this Parallax system will run before the render system because we need the okay, I hope I'm back. So because we need the background to be the first one to render. So that's why we need here the game viewport and also the game camera. Let me take that over as well to this little system. But that's then everything that we need. We already have the game camera. Perfect. Okay, so this system is very simple. It's just like game viewport apply and then finally batch use the game camera. And in here we call the draw method of our Parallax background. And hello, Misha. Is that what is this language actually called? So for me it's Russian, but it's obviously not Russian. How do you call that? Russian letters? Oder russische Buchstaben? How's that called? Kyrillisch. How do you say that in English? Kyrill? Kyrillisch? Cyrillic? Is that the correct name for the letters that you are using? And are those letters representing the name Misha? By the way, I don't want to offend you, but when I hear the name Misha, I think of... Wait. That one here. Not sure if you know that. That's from... I know it from Warcraft 3. Most likely it's an important character in World of Warcraft. But it's the bear from the Beastmaster. That one is called Misha. That's the one that I think of when I hear that name. No offense, that is not meant in a negative or positive way. It's just something that comes to my mind when I hear that name. Good. Parallax background draw. And what else do we need? We need the calculate parallax vectors, and that one is basically the distance. So it's the parallax x. Let's call that para x is equal to game camera dot x. No, position x minus 0 because it's the distance to the origin, which does not make sense at all. So it's just the camera position x. So I don't need that at all. That's interesting. It's my name. It's reading that. Okay, so I got that right. We need something else. So currently we can scroll the background, which is nice if we want to have an effect like this. So an endless scrolling background, that's good. But in the game, we don't want that. So we don't want to move the background all the time. At least I don't want that. So instead of scrolling, we need something like, how do we call that? Scroll to. Maybe this is a scroll by. Not 100% sure how I should call those methods. And this is a scroll to. And there we would have the X and Y. Let's call that scroll X and scroll Y. And how does that now work? So here I think we need basically the original values. Which I don't store somewhere. Maybe we should do that. No, I don't need that. I also have the width. So the width of the sprite is the world width. So I have the world width, which is the, let's make that here equals with the background sprite so that we have everything available. So I have the width of the sprite, the height of the sprite divided by the texture width and texture height. Those are the original values plus the scroll amount and here plus the Y amount. I'm interested in the outcome when I finished implementing everything. If that is working at all, I don't know. Let's see. So here we want to call scroll to, and it's actually game camera position X and game camera position Y. Then let's remove the parallax background from here. And in our game screen, before our render system, we will add this parallax background system. Also good stuff. That should work. Let's see, how does that look like now? What kind of effect do we achieve? We have the effect of a crash. There is no injectable with name camera. It's called, I think, game camera. It's an orthographic camera. Okay. Okay. So when I move, I see the background moving. So I think on the... So here the camera does not move anymore. Which is correct. But when I move to the right, then it's moving a little bit. So, whoa. When we jump, there the effect is super crazy. So I would definitely say on the y-axis we multiply it with a smaller value. But on the x-axis, actually, I want to have it a little bit bigger. Let's see. Now it's not moving at all. I mean, it's moving a little bit, but not too much. I don't want to have a disturbing background effect as well, so maybe that's already good enough. But I want to have it a little bit more, just a little bit. Let's try those values. So the background is now moving it seems like exactly with the player, which is a little bit weird. And when we go left and right, there... I think left and right, the speed here is okay from the background. I think that's totally fine. And the Y should be a little bit different. So we multiply it currently with a quarter. Let's make it half. That's now too much again. Let's make it 1/3. I think that looks good. Yeah, I'm happy with that. Also with the way it scrolls to the left and right, that's also good. Yeah. To me, that looks good. I want to set these speeds, however, on the background itself. So I think there should be like a scroll speed. Shall we call it like that? So that we have a scroll speed, which by default is 1 and 1. And then whenever we are modifying something here, we multiply with the scroll speed X. And here with the scroll speed Y. And same here. And here I said that I don't want to calculate that all the time. Also, by the way, in the Parallax background system, I think we should also remember the last position of the camera. And if nothing has changed, we don't need to call the scroll to method at all. Otherwise, it's always making this tiny little calculation here, but I think it does not matter at all. But what does the fox say? What does the frames say? We still have maximum. Okay, little bit of a frame drop shortly after the game has launched. I think there we are disposing the stuff from the loading screen that's randomly done by the JVM. But other than that, seems like we have maximum frames. Out of interest, what is really the maximum amount of frames that we get? So we have this LWJGL application. No, it's not that one. How is that? Something launcher. LW something launcher? No, how is that thing called? Why did I not find that? Then let's say use vsync false and let's go crazy. Okay, so we have over 2000 frames per second. About 2400, 800, 700, 600, 700. So a lot more room to spare. So we are by far away from the limit. So I think we don't need to add this optimization that I just mentioned. But still, this one here, that one I want to keep at least or calculate it. That would be the, how do I call that? Maybe something like original or origin UV. And that one gets set inside the vector 2 here. So there we have, let's call that also origin UV2. And that one is exactly those values here. Zip and zip. And then we have here X and here the Y. And now we can reuse that here below. So that first part we don't need to calculate all the time. The same here. Also good. And yeah, I can skip this one. Wait, since it's now only used here, I think it's better to have it like this. Okay, so now we just need to set the scroll speed, which is currently private, which we don't want to be private. We want to set that, and we could set that in the... I'm thinking of maybe make the Parallax background class inside the background system. And when we resize here, we could fire an event, like a game resize event. Maybe other things in the future might be interested in resize events as well. Then we have a generic solution, which I like the most. And I think we will go with that. So let's clean that up a little bit once more. And we are almost done with the Parallax background. So what we want to have is here like a new data class. Let's call that game resize event. That takes the width, which is an integer, and the height. And that one we will fire generally. So in our Billy Jumper game, we have create, we have render. We have a lot of fancy things. And before the render, we want to have a resize. And that calls the normal resize stuff. And in addition, from the dispatcher, we fire an event, which is the game resize event, and there we pass in the width and the height. Okay, then in our game screen, we can now remove the Parallax background, which I don't really like here, because I want to have that in the Parallax background system. So we create it here, we don't inject it. Then in our game screen, we can now remove here the resize, and we can also remove this here as an injectable because it's not needed. And we don't dispose it here, but we dispose it in our system here. So Parallax background, dispose safely. Good, good, good. And finally, I think the game screen is now cleaned up. Finally, in here, we are now setting a speed. I think that would be the best if we have it here at the top. It's vector 2. Okay, and the scroll speed that we are having is actually vector 2 with 5 and the values that we had here below. So now we don't need to multiply here anymore by that one. Okay, I hope that everything is still working now. No. Huh? What? Why don't we have a background now rendered? I don't get that. What did we do wrong? We broke the background class, I could imagine. Why? We have resize. We have here world width, world height. We have the U2, V2 stuff. Ah, ha, 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 ha. I know. So first of all, we need here the event listener. What? No, not event listener. How did we call it? Game event listener, right? Okay. Yes, that's the one. Then we need the on event. method. We don't resize currently. That's our issue. And basically, if event is a game resize event, if it's not a game resize event, then return, and otherwise Parallax background resize with event width and event height. So that should work. Now it should work. Haha. Okay. I'm not. Are we really calculating correctly? 1, 2, 3, 4, 5, 6. 1, 2, 3. It feels like we are stretching the background. Now it looks correct. So I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these squares. And here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's way more. I think that's correct. That's not correct. Why? So we have here the game viewport, world width, world height. World width, world height. Let's see, what kind of values are we calculating here and what are we actually setting? So we have a world width of 16 and a height of 9. So the origin v2 is 4 and 2.25. Now we get a world width of 640 by 360. What? Ah, that's... Yeah. Wrong. Let me think. This is... Wait. Wait. I know the problem. So the problem is here. We resize here to the event, which is not correct. I'm wondering now something. So here we resize, which means we resize the screen and all the viewports, and then we are firing the event. So at that point, we know the viewports are up to date, which means in our case, we just need our game viewport world width again, if that changed, but most likely no. And also the world height. That's it. But in the test screen, what did we do here actually? So this is not correct. No, that's not correct. And does the update even update the world width? No, it does not do that. I think we never need to resize the parallax background. I think that was a mistake by me, because that's actually the reason why we use viewports in the first place. We have a fixed world size. We have a fixed world size and we are not interested in the screen size actually. So we never need to resize the parallax background. No, that was a mistake. So this entire method is useless. And we can remove some code pieces again. So resize We don't need that. Then here we also don't need to override here anything. Then the test screen. We don't need to resize the background. And also in our Parallax background system, we don't need an on event, and it does not need to be a game event listener. Okay. First of all, let's try the test screen once more. Now, I would be interested. Now the flickering is also gone. Haha. Now the flickering stuff that we had at the beginning is gone. So the resizing was basically not correct. It was basically wrong. Okay, that looks good. Now let's try that out once more in our game. And there I don't have this background now. Why? Because this... Actually, I don't know why. This thingy here gets created. Yes, with the correct values 4 and 2 something. And size is 16 by 9. I am confused. That's also not... So before it was way better. What's currently happening? So this thing... gets drawn with a size of 16 by 9. Let me think that through. That is maybe okay. I call here a resize. What is a resize? It's this one here. Okay. Okay, so step by step. First of all, I see one issue. So since our map is way bigger than this 16 by 9, we would need to not just draw the parallax background like this. We also need to set the position. Which currently I cannot set. Maybe it should be part of the draw method. So there I pass in the game camera position X, but that's the center of the camera. So we need to move away by the viewport width. Is that correct? Let's make it not correct, but that we have a little bit of a better understanding of what's happening. So we need on the draw function, we need to have here the X value and the Y value. And what we do, we set the position to X and Y. So in our test screen, since we don't move around, we render it at the origin, which is 0, 0, which is good. But in our game, we have it now centered at the camera, yes. We would need to move it now to bottom left. But it gets tiled way too many times. It should be just 4 tiles. Why is it so much more in the game? We obviously do something wrong because in the test screen, there we have the correct behavior. There we have this repetition of 4 textures on the x-axis and 2.5 or 2.25 on the y-axis. So this is correct. Also the flickering is gone. So everything is perfect, but in our game we do something wrong. So that's good to know that the test screen is working and perfect. So obviously our system is doing something wrong. So it creates a parallel background for the game viewport. The game viewport world width and world height is this 16 by 9. Yeah, so we are calling resize, and that's the only location where this resize is getting called. Then in addition, scroll 2 is not correct. I understand this now. So we also need to set, like here, we also need to set U and V, which we currently don't. Okay, I think I have it. So now we just need the original UV, which we can... Isn't original UV always 0? Yes, it's always 0. In our case, it's always 0. So we would not need to store it at all, but just for the future, if that maybe changes, we will keep it like that. So resize, which is UV. Okay. And finally down here, we now set the background sprite U is equal to the original UV X plus the scroll X multiplied with that one here. And here we have background sprite V. It's original UV Y plus scroll Y multiplied by the scroll speed. Okay, I forgot to set those indices. Now it should be better. Yes, that looks now a lot better. It's moving way too fast, but we can fix that. What we do need, however, we need to adjust the position once more, which is, I think it's game camera position X minus game camera viewport width, half of it. I think this one, and here it's also minus game camera viewport height, half of it. Yeah. That should be it. Haha, looks good. So resizing now does not destroy the aspect ratio. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then it's scrolling. But since we fixed and changed a couple of things, it's now scrolling way too fast. Okay, so we want we have here 5. Let's go back here to 1. Maybe that one is even too fast. Yeah, I think that's even still too fast. So let's make here half of it. And here also reduce it once more. I think that feels good, right? Maybe a little bit too fast on X and Y. On the X-axis, on Y. Y maybe also a little bit too fast. Let's go down here to 2.5. Here to 0.5. So now X is not moving at all. Y feels okay, I would say. Yeah, I think that's okay. But that one here needs to be a little bit faster. It's a me, Mario. Hello, Mikey. Okay, so now it's moving the opposite direction, which is good. The Y should actually... It's actually the wrong direction, so Y should be... minus game camera position. I don't know. Still feels weird. I really don't know. Well, let's increase that speed once more. So what I want to do when I jump, the background should not go up, or should it go up like that? But it's too slow now for whatever reason. I don't know why it's now slower. Let's take this value here. Now it's too fast again. We are almost there. Step by step to perfection. Okay, I think that's good enough. So we can see that the background is moving a little bit here. So here the square is cut off, but when we jump, we can barely see it. So that's good. When we move left and right, we see the background scrolling a little bit. I think that's also good. It's maybe a little bit too fast. I think the background is a little bit too fast. So let's make it also here 2. But when I used 2.5, then it did not move at all, right? Wasn't that the problem? Now it's moving a little bit. Yes. I think we keep it like that. So you can feel that the background is not static, that it's slowly moving. But it's a little bit hard to tell with the background graphic that we have. But I think it's good enough. And now let's just go over all the different changes that we made again. So profiling, we don't need that anymore. There was no big impact at all. Then we had the Parallax background system. Okay, then we had the graphic. We don't care. Then the background class, and there he says, could be private. Yeah, you say that. Then make it private. Might be in the future necessary that you change the scroll speed depending on the different background textures that you have, but we just have one and we only support one. So we don't need that for now. That's good enough for us. Then we have the Parallax background system. That one is also good. Let's refactor that, not really refactor it, but let's call that here Parallax. And that one here is the Parallax Y value, and then bring that back to a single line. Then we had the Parallax test screen. That one was quite useful. Short one. Then physics system, that was that one I want to commit separately to have that in the Git history correctly. Fix camera focus for the first couple of frames. Okay, that was this tiny little fix. Then we had the render system where we actually did not change anything. So let's revert that. Then the map. What did we change with the map? There we played a little bit around with the layers, but I think we can also revert that. Then the test launcher, we keep that. And the project. Okay, one final test. So game launcher, perfect. We are here. Parallax background is working. Great stuff. When we jump off the map, we respawn with full life. Yes, everything seems to work like a charm. Good. Add Parallax background. Ta-da! Wonderful. And that's it for today. I'm done. Any wishes from the viewer side? I might be online some more, maybe half an hour. If you don't have any questions or if you're not interested in anything else, then I would stop the stream here. But if you are, then let me know. Good. So also here we can tick that off the list. A feature a day keeps the doctor away. Done. So what do we actually have here? Implement double jump feature. Support game object spawning from tiled. I think that is already working. Contact listener in physics system. I don't know why I took those notes. But yeah, the double jump feature, and that one we will implement tomorrow. So let's just move that to the next day. The days are anyway already screwed up. And tomorrow we will then have the double jump feature. What did I mean with map transition? We won't do that. There I have another idea. We will just make a main menu where you can select. Let's just make it 2 maps. Or 3 maps. 2 maps. The tutorial and the, I don't know, map 1. And move current test map to test resources with a separate test screen. So this is more like a minor cleanup. So what we just need is this one here is not correct. We will create 2 maps. One of them will be the tutorial where you learn the basics, the movement, jumping, maybe damage as well. Let's see. And then a real map with the, just a tiny little map with the rocket enemy, the saw. And we need a goal, right? Currently, you can run through the map, but you never reach a goal or finish a map. Is there a graphic? So maybe just a game object that we touch, and when we touch it, then the map is complete and we get back to the main menu or something. Very, very simple, nothing complicated. And for that, what could we use? By the way, background graphics, we had gray. Maybe we should also try out the green background as well. Let me quickly copy that over because that's easy to add with our current way of implementation. Green has hopefully the same size. 64 by 64. Yes, that's good. And then also, is there like a pole graphic or something like that? So something that we can grab and win? Items, boxes. No, we don't need boxes. Checkpoints. And nah, I don't want that as an end checkpoint. The flag. That looks good. Checkpoint, no flag. Checkpoint, flag out. There's even an animation. Maybe that one. Maybe we have a flag without that. And when you run or when you touch it, then it simply opens up the flag. And then the map is finished. Let's see. Is there something better? There's also a start graphic with a start moving animation. Okay. Maybe also something that we could have as polish for the final game. What else do we have? What is other? Other is bullshit. We don't need it. Then we have a couple of other things. Terrain. No, we have that one. Traps. I don't think so. No, that doesn't look good. What is a trunk? Is it a tree? Ah, no, that's an enemy. Okay. And the turtle. No, then I would say we will use the, how was that called? Other goals? No. Items, checkpoints, items, checkpoints. And there we have the checkpoint no flag. And then checkpoint idle. Okay, I think we need all three of those. And in addition, let me open that up. So this is then for the final polishing of the game. So we need object. Then here we had flag maybe. These are those graphics. And we also need maybe a start. That's also nice. Just this one at the beginning of the map that you know you need to go in that direction. I mean, everyone nowadays knows that, but still useful if we want that. Some nice touch to our game. So the start. Okay, then let me also write that here. Create two maps. Polish the game. Add checkpoint flag at the end of a map. When player touches it, play flag animation, stop player, and go back to main menu. So we need to implement the main menu first. Then this is maybe something like the finish. Those are those two things. And then add start sign to beginning of the map. Good, good, good. So tomorrow, what will we do tomorrow? Most likely we're pretty sure we cannot finish everything because tomorrow I also meet my friends, two different group of friends. One group at lunchtime, one group late in the afternoon. So most likely we will not be able to implement everything, but I want to implement this one here next so that we pick up some fruit and then we can do a double jump so that we can jump in mid-air again. That should be part of the tutorial as well. That would be good. And maybe we can also finalize a main menu. There I'm not sure because I'm usually very slow with user interface stuff, but might be. But other than that, I think we are not able to finish the game this week, but we will be able to finish it by next week. There I'm pretty confident that we will be able to do that. And yeah, this one here, someone mentioned that, but I'm honest, there will be no time for that. I am only here for 1 more week, then I'm on my holiday. And when I'm back with my family, most likely I don't have time anymore for streaming. Or until I stream for the next time, it will be a very, very long time again in between. And then I don't remember this project again, and I don't want to start then with that. So this is some extra exercise. The guy who raised that, maybe you want to implement it yourself. Let me know, write me an email, and then I will demonstrate it in a video. But sorry for that, I won't have time for it. I just want to finish and polish up the current game that we have. And that's it, but that looks good. So quite a journey that we had so far, but a good one. So we achieved something and I like it. I'm happy. Good, then I wish you a nice rest of the evening. Thanks for watching and see you again tomorrow. Bye bye.